Why hello lovely humans, Jen Foxbot here for another exciting edition of Math Mondays. No. Alright, so in this episode we're going to talk about mathematical notation because I got a question about what the heck is the deal with all of these Greek letters showing up in my math equations. It was paraphrased much more gently than that. But I thought that was a really great question. And it brings me to the thing that I love to say all the time is that math is just a language. And just like any other language, we all have to agree on the symbols and their meanings in order for it to have meaning and for us to communicate effectively. So that's really the same exact thing in mathematics. And math is a constantly changing landscape. New concepts are discovered and old ones are revitalized, and sometimes folks will be like, this number shows up all the time. Let's tack that as a constant and give that a symbol that is easier to write than this super long number. And so you'll find this as you go into physics or higher level math. It's a way for folks to be lazy and to save a lot of time in writing. It also makes communicating more complicated concepts like special types of functions. For example, in calculus, the derivative has a bunch of different ways to represent it, and I'll talk about those in a little bit. But first, why Greek letters? Well, this would be something that a historian would be able to talk about much more accurately, but from my understanding, a lot of it is just historical context. A lot of the Greek folks did math that we, or in Western culture, built on top of, and so those things just kind of got brought along with them. Pi, boom, is a perfect example of that. So most of us will recognize this as the constant used to represent the ratio between the circumference and area of different circles. And so at some point, most of us had to memorize that pi is the number 3.14. For those of you that went above and beyond in math class, you'll memorize more of those digits than I did. But we use this symbol to represent this number because pi shows up all over the place. When we're calculating areas of circles, when we're calculating things that have to do with degrees or angular motion, things where we're turning and stuff like that. It's a lot easier to keep track of pi as a single symbol, as an individual symbol, than it is to drag along this number with us. So that's the first thing, is that symbols allow us to be lazy. So that's a real like thing to want, right? Especially when your equations become pages and pages long, it can be a pain to drag that through. And the second thing is that having a symbol allows us to change our equation on a whim. So for example, if I just wanted to loosely estimate the area of a circle, I might use 3 for pi and call it good, because I'm just trying to get a rough approximation. However, if I'm a structural engineer or I'm trying to buy parts for a circular fence, I need precision, especially if I have little tiny animals that can squeeze through that fence. A few inches of fencing might make a huge difference. This also shows up when we're calculating trajectories to other planets, because a tiny error in our equation might mean that you're off by miles or even more. So that's a problem. So by using a symbol, we can track through the accuracy, or we can change the accuracy on a whim. So if I need more digits, I can just toss those into my equation without having to rewrite the whole process. Cool, so those are the two main reasons: laziness and accuracy. And so when it comes to Greek letters, we reuse Greek letters all the time to mean different things. So even though pi is most commonly used as the constant 3.14, we also use pi in other areas. So for example, in economics, pi refers to interest rates of certain things. In particle physics, there is a particle called the pi meson, and it's represented with the same Greek letter. Gamma, that's a horrible looking gamma, but that's fine, or lowercase gamma. Greek letters are just like the English alphabet, they have upper and lowercase. So gamma often represents gamma rays and light photons, or particles of light. But it also represents different things in structural engineering. It represents partial safety factors in structural engineering. I had to check my notes for that one. It also represents the heat capacity ratio in thermodynamics and specific weight of substances and fluid dynamics. So this one Greek letter can mean lots of different things depending on your context. So if you go to read a math paper or a physics paper or something like that, and you see different symbols, it can help to look up the context of those symbols, because every specialty has their own flavor of the Greek letters, if you will. All right, cool. So the last thing that I wanted to do is to look at calculus notation, because I think that this point really drives home the fact that notation is oftentimes a matter of opinion. There are actually 4 different ways to write derivatives in calculus. That's a lot of different ways. So, as an example, let's say that I have a function that depends on x, and my function is, I don't know, x squared plus 4x plus 2. If I want to use Lagrangian notation, I'm going to represent with an LA. Lagrangian notation, which is my personal favorite, is also called prime notation, because you use primes to indicate the number of derivatives that you have taken. So for example, the first derivative of f with respect to x would be f prime of x. Then you take the derivative, 2x plus 4 plus 0. So that's Lagrangian. Then you also have Leibniz, which I'm going to represent with an LE. And Leibniz notation is actually the most common in introductory calculus. So this is your familiar d dx, which acts on a function. Sometimes if you are using y instead of f of x, you would see, dy dx, and then that equals the same thing, 2x plus 4. Again, dy dx is the same thing, so I'm going to erase that to give myself some more space. So that's Leibniz notation. You also have Euler notation. This one is not super common. It's kind of weird to me, at least. But you use a capital D, and typically you'll have a little subscript to tell you what derivative or what the respective variable is. And then it usually acts on your function, f. Oh, no. F. Okay, well, there's an f there. Again, same thing, 2x plus 4. And then lastly, you have Newtonian notation, which is called dot notation sometimes. And so this one, you have f dot equals 2x plus 4. And to do a second derivative, you would add a second dot. So 4 different ways to write the symbol that tells you to take the derivative. And it's kind of funny, Newton often gets the credit for inventing calculus, but Leibniz got the most common notation. And then Lagrange, who kind of pops up everywhere because he was a brilliant mathematician, ended up kind of coining a very popular notation that's used in upper level math and physics. So again, notation is just a way for us to communicate, and Greek letters are used because it's faster to write and it's easier to keep track of symbols than it is to keep track of numbers, especially when those numbers can change. So like I mentioned, if you're talking about, if you're doing like fluid dynamics and you're talking about how well a material transfers mass or heat or something like that, then it's easier to use a variable, because that way you can change the substance that you're talking about, and then plug in the numbers at the end. So you can run the equation through, solve for the thing that you're interested in, and then apply the numbers at the very end. And that saves a lot of time. It's very similar in programming, how you declare global and local variables that make sense. So like sensor pin, for example. And that way you can call the sensor pin wherever you need it. And if you happen to change how you've connected the sensor to your controller, you don't have to change that number throughout. You just change it where you declared it. All right, cool. So hopefully that makes sense. Please let me know if you have any questions about anything that I talked about here, or if you have any questions about Greek letters or symbols in general. And of course, you can always look up these things online. There's a great Wikipedia page on Greek letters that are used as mathematical symbols. Cool. And then lastly, please send me your most pressing math questions and we will solve them together. All right. See you next time, and thank you very much for watching. Bye!